So before I get into the different area formulas, I just want to clarify what is area. So I'm sure you all know what distance is. Distance is the measure of one-dimensional space. So because it's one-dimensional, it can only go horizontally, which is sideways, or it can go vertically, which is up and down. Now, area is the measure of 2D space. Because the first line that I've drawn is horizontal, the next thing we're going to do is take this horizontal line and we're going to drag it vertically, say 2 boxes. We've now created a 2D shape. In this case, it's a rectangle. Now you might be wondering, okay, well, we know what area is now, but how do we calculate it? Well, let's take a look. Let's start with a square. A square is classified by all sides being the same length, and all angles must be 90 degrees. Let's take a look at this square here. We can see that it goes up by 4 boxes and across by 4 boxes, which means we satisfy the first condition that all sides must be the same length. The second condition is that all the angles need to be 90 degrees, which we can see by this little square in the corner. That shows that it's a 90-degree angle, so we know that this is definitely a square. Now, if I were to ask you, what's the area of this square? The first thing we could do is we could just count all the boxes inside. And we know we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can say that the area of this square is 16 boxes. Now this works for this example, but it might not work for more complicated examples. So we want to know how can we figure it out in other situations where the numbers might be bigger, where we don't have squares in the background to show us. Now, to figure out the formula, we can just have a look at the side lengths that we're given. We know that we're given 4 squares going across. So we can see that for 4 boxes that we go across and 1 box going up, we've got 4 boxes. Now, how many of these can we stack on top of each other? You're right, we've got 4 of them. Which means we're going to have 4 times 4 boxes. And 4 times 4 is 16. We can see that we get the same answer, which means that it must be right. Let's have a look at the second example here. Now, we've got another square, and we can see that we've got a right angle, and our side lengths are the same. So we definitely know that it is a square. Now, without counting the boxes, how can we figure out what the total amount of boxes is that we've got, or in other words, our area? Right. We multiply 5 by 5 together. What's 5 times 5? 25. Perfect. So our area is 25 boxes. Now let's take a look at this third example here. We're not given how many boxes it's up or down, but we're given a unit of measurement instead. In this case, it's our one-dimensional distance, centimeters. So we're told that our side lengths are both 6 centimeters long. So we already made the first condition, that all side lengths are the same. Now the second condition that we need to check for is what? Exactly, that all angles are 90 degrees. So we know that this is most definitely a square. Using the same principle as before, how can we figure out our area? What do we need to do? Great. We multiply 6 times 6 together to figure out our total area, this time using the centimeters. 6 times 6 is 36. Now, what happens with our centimeters is that in the same way we're doing 6 times 6, our units are going to be centimeters times centimeters. And centimeters times centimeters gives us centimeters squared, where the 2 means that we're multiplying centimeters by themselves twice. Let's have a look at this last square right here. Once again, we'll just triple check that it is actually a square. Our side lengths are the same. This time, we're not given a distance or an amount. We are just told that it is S long. But they're still both the same, so we meet our first condition. Second condition is that all the angles are 90 degrees, which they still are. So this is still most definitely a square. Now, how would we find the area of this one? What have we done with every other square? We've multiplied the side lengths together, right? The horizontal side length by the vertical side length, which means in this case, we will have S times S. Now, this can be simplified in the same way that centimeters times centimeters became centimeters squared above. S times S will become S squared here. So we now know that the general formula for finding the area of a square will be S squared, where S is the side length. Now, I want you to pause the video and have a go at these 3 examples by yourself, and then come back to check your answers to see if you are right. So, using our area formula, A equals S squared, we need to just substitute our side length in place for where the S is. So we will get 3 squared, or 3 times 3, if that still makes more sense to you, which is 9. Now, it's really important that we don't forget our units. Our units are centimeters, so we need to write centimeters squared. Having a look at example 2, we always want to start with our formula, A equals S squared. Now, our side length in this one is 7, so we will be using 7 squared, or 7 times 7. Both are still correct. 7 squared is 49, and once again, we also need to make sure that we write our units. In this case, we've got meters, which means we'll have meters squared. Lastly, we've got example 3. Our area formula for a square is A equals S squared. Our side length is 9, which means we'll be using 9 squared, or 9 times 9, which is 81. Our units are millimeters, which means we write millimeters squared.